In this video, we're going to just define what the Laplace transform is, and then sometimes the best way to understand the definition is to work through some examples. So then we'll work through some examples of finding Laplace transforms of some common functions that we'll see. So what the Laplace transform of a function f of t is, so we're going to take some function f that is a function of t, and it's going to be defined for all values, at least for all values of t greater than or equal to 0. Then we define the Laplace transform of this function, which we denote with this script L. So we're going to apply the Laplace transform to f, and we oftentimes denote this with a capital F. So just like when we integrate things, we oftentimes denote an antiderivative with a capital letter. When we apply the Laplace transform, it's an integral operator, so the result that we get out, we're going to denote with a capital F. And it is defined as the improper integral as t goes from 0 to infinity of e to the minus st times our function f of t dt. So there are a couple of letters floating around in here, so it's good to just note that we start with a function of t. And so initially we're going to integrate this with respect to t, which means this other letter s we're going to treat as a constant. So after we evaluate this integral and plug in our limits, what's going to be left is a function of this variable s. So for now, we're going to treat s like a constant, and in the end, what we're going to get is the Laplace transform is going to be a function of this variable s. And so the domain, the resulting domain of the Laplace transform is going to be all values of s for which this integral converges. So there might be some values of s where the integral converges, there might be some where it diverges. So we're going to define f only on the interval of s values for which this integral converges. And then we call these functions f and f a transform pair. Okay, so we call this the Laplace transform, and again, what it's defined as is the improper integral from 0 to infinity of e to the minus st times our function f. So that's the definition, and I want to walk through some examples in some separate videos. In this video, we are going to calculate the Laplace transform of a constant function f of t is equal to 2. So we're going to denote this again with a capital F of s, and we can denote this as the Laplace transform of 2. So we use this script L to denote the Laplace transform. So if we're taking the Laplace transform of 2, then by definition, this is the integral, the improper integral from 0 to infinity of e to the minus st times our function, which in this case is 2 dt. So our function here is just the constant 2. So we want to evaluate this improper integral and determine for what values of s is this improper integral going to converge. So here we're going to take the limit as the upper limit heads to infinity. So we're going to do this carefully. And when we integrate this, the 2 comes out. We get a minus s that comes down. So we're going to integrate this, for example, using substitution with w equals minus st. And integrating and then substituting back, we would get 2 over minus s times e to the minus st, which we evaluate from 0 up to n, which is heading towards infinity. And so integrating this would give us, or excuse me, evaluating this at the limits, we've got the limit as n goes to infinity of 2 over minus s, and remember our variable here is t. So we're going to plug in this value for t, and then we subtract what we get when we evaluate it at 0. And again, we're plugging these values in for the variable t, and we're treating s like a constant. And so now let's think about this limit, which is with respect to n. So the 2 and the minus s are constants, and we can pull them out. So what we really want to consider is what happens to this quantity as n goes to infinity. And if we have something like e to the minus large number, that's going to head to 0. And if instead I have e to a positive large number, well, then that's going to head to infinity. So depending on the value of s, we may get something positive, we may get something negative. So as long as s is a positive number, then minus s times something which is heading towards infinity is going to put us in the case where we have e to a large negative number on top. And when that happens, so what I can see here is that as long as s is positive, then this is going to converge to 0. If s is less than, or I guess I can include 0 here, but if s is a negative number, then what's going to happen is we would actually be in this case, and that would be a situation where the integral would not converge. So as long as s is positive, this part is going to go to 0, and over here we get minus a minus 2 over s. So there we go. There's our first Laplace transform. We just found that the Laplace transform of the function 2 is equal to 2 over s. And the domain here is going to be s is bigger than 0. So as long as s was positive, then that piece where n was going to infinity would converge to 0. And that overall makes our improper integral converge to 0. And we can generalize this really. If I had the Laplace transform of 5, really the only thing that would change would be the 5 that got pulled out. So in general, if we're taking the Laplace transform of some constant k, it's just going to be k over s, as long as s is bigger than 0.